A new study by a physicist named Eric Lenz from Göttingen University in Germany has shown, at least hypothetically, how space travel faster than the speed of light is possible so we can reach faraway planets. The study was published in Classical and Quantum Gravity. When it comes to space travel, to be perfectly honest, it is an area that we humanity have not accomplished much yet. We have gone to the moon, but that was a while ago, and we have not gone any further than that. We have sent probes out in space, but not actual humans, since it is not safe to send humans out that far. Also, the probes move at a very slow pace. There is talk and plans to send humans to Mars, but it has not yet, at this time, actually been done, though it could change. As for going past Mars or to other solar systems, that cannot be done. It would take thousands of years to get even to the ones that are close to us with the space travel technology we have now. Now, part of the reason for this is because space travel is a hard thing to do because space is so vast. We would need something that goes at the speed of light or faster to be able to get to other solar systems and other parts of our galaxy in a short or normal time period. According to Albert Einstein's theories of relativity and what some scientists think today, it is impossible to reach or go faster than the speed of light. This does not stop many of us, particularly physicists, from trying to find a way to explore space. This study by Eric Lenz seems to have found a way around this problem. For more information about it, I'm quoting from ScienceAlert.com here. Quote, "While pushing matter past the speed of light will always be a big no-no, space-time itself has no such rule. In fact, the far reaches of the universe are already stretching away faster than its light could ever hope to match. To blend a small bubble of space in a similar fashion for transport purposes, we need to solve relativity's equations to create a density of energy that's lower than the emptiness of space. While this kind of negative energy happens on a quantum scale, piling up enough in the form of quote-unquote negative mass is still a realm for exotic physics. In addition to facilitating other kinds of abstract possibilities, such as wormholes and time travel, negative energy could help power what's known as the Alcubierre warp drive. Hopefully I'm pronouncing that Alcubierre right. This speculative concept would make use of negative energy principles to warp space around a hypothetical spacecraft, enabling it to effectively travel faster than light without challenging traditional physical laws." End of quote. Now I just want to pause there and say this sounds like the warp drive in Star Trek, which works in a similar way by using negative energy or antimatter to warp space and time around the starship to get through it faster. This is of course science fiction, but it often was ahead of its time when made, and if this study is correct and technology like this is developed, someday Star Trek will have predicted the future, as it has done with other things before. Anyway, back to the article here. I'm continuing to quote it. Quote, "Except for the reasons explained above, we can't hope to provide such a fantastical fuel source to begin with. But what if it were possible to somehow achieve faster than light space travel that keeps pace with Einstein's relativity without requiring any kinds of exotic physics that physicists have never seen? In the new work, Lenz proposes one such way we might be able to do this, thanks to what he calls a new class of hyperfast solitons, a kind of wave that maintains its shape and energy while moving at a constant velocity, and in this case, a velocity faster than light. According to Lenz's theoretical calculations, these hyperfast soliton solutions can exist within general relativity and are sourced purely from positive energy densities, meaning there's no need to consider exotic negative energy density sources that haven't yet been verified. With sufficient energy, configurations of these solitons could function as quote-unquote warp bubbles, capable of superluminal motion, and theoretically enabling an object to pass through space-time while shielding from extreme tidal forces. End of quote. This is not exactly like the warp drive in Star Trek, but it is very similar to it. I don't think this study mentioned anything about using dilithium crystals like they use in Star Trek. This study has a lot of interesting ideas. Whether they prove to work remains to be seen, but still, nevertheless, they are quite impressive. There also is another study that came out very close to the time this study came out that studied the same topic about space travel at a fast pace. This study also suggests the idea of a warp drive and how it would work, but unlike Eric Lenz's study, it does not work exactly the same way. So these two studies are very similar, but differ how exactly it would work. The makers of these two studies have gotten in touch with each other and shared their ideas, as well as further discussed this topic so greater knowledge can be learned about it. Eric Lenz discussed his research further in a YouTube live stream on March 18th, and a video of it is on YouTube, and I have the link in the description of this video for it. Eric Lenz also said, quote, "This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering," end of quote. So while this has yet to be tested to know if it can be used, it is good that progress is being made in this area, even if it is a first step or a beginning step. We have heard for a while that space travel to other solar systems and parts of the galaxy was impossible and is just something in science fiction, because we could not go at or faster than the speed of light. But it is good to hear, according to these studies, that they have found a way around it, and it is indeed possible to travel to other parts of the galaxy and other solar systems. So as always, we'll wait and see what comes of this, advancements in space travel, but we'll see. Thanks for watching, and please like and subscribe if you've not already done so. Thank you very much.